Hi students, today we will go with a shear design, that is a shear design of a PSC beam. This is a first problem under that. Few steps we have to follow it. We will be doing the problem, go through the problem first, that is the support of the support section of a PSC beam 150 mm by 300 mm is to resist a shear of 100 kilonewton. The pre-stress at the centroidal axis is 5 Newton per mm square. FCK is equal to 40 Newton per mm square. The cover to tension reinforcement is 45 mm. Check this section for shear and design suitable shear reinforcement. Ft is equal to, that is given, data is Ft is equal to 1.5 Newton per mm square. So we'll go with the first steps only. So first step, you have to calculate external shear force. Here shear force is given, but it is not mentioned is it is a factor load or not. So you have to calculate ultimate shear strength by multiplying with a factor of safety as 1.5 into 100. So 100 kilonewton is given, so I multiply with 1.5, so you'll be getting as 150 kilonewton. Go with the second step. Here internal shear resistance is that is nothing but a symbol is Vc naught, we have to take it, and Vc naught is equal to 0.67 B into D square root of Ft square plus 0.8 FCP into Ft. So this you no need to remember a formula. You can refer page number 46 of IS 1343 code book. So next, that is I will be substituting for this one. Vc naught is nothing but 0.67 multiplied by breadth is given in this question as 150 and depth, overall depth is given as 300. So square root of Ft is given here, that is 1.5 square plus 0.8 into 5 is given here, you can see it, that is a pre-stress at the centroidal axis, that is nothing but FCP multiplied by 1.5. so next, that is Vc naught, you will be getting as 86.6 into 10 raised to 3 newtons, or you can convert into kilonewton. So comparing here, you have to do a comparison. Is it Vc naught is higher than Vu, that is acting force, resistance, this is nothing but resistance, and this is nothing but resistance of a concrete. Okay, this is nothing but Vc naught is here. In this case, Vc naught resistance power is less, so you have to go with a provide shear reinforcement. 86 is lower than 150 kilonewton, acting is more, so you have to provide shear force. Otherwise, if suppose this is vice versa, that means shear force acting is less than a resistance, that means resistance power is that is concrete strength is higher than the acting force, then you have to give a minimum shear reinforcement. In this case, it is higher, acting is higher, so you have to provide shear reinforcement. So as you done in RCC, same way you have to do it here also. The first step, you have to assume as that is 8 mm vertical stirrup is having two-legged means a stirrup is provided in this fashion, right, in this fashion. So reinforcement will be here, main reinforcements in RCC you studied it. Okay, so this is nothing but two-legged, one leg and two leg. So two-legged vertical stirrups of 8 mm diameter, I assumed it. We check it, is it sufficient or not. So ASV you can calculate, area of steel or vertical stirrup. So 2 into pi by 4 into 8 square, so it will be 100.53 mm square you will be getting. So we will be moving forward. So here, that is ASV divided by SV, this is equal to Vu minus Vc naught divided by 0.87 Fy dt. This is you can refer in page number 48 of the code book, that is IS 1343. IS 1343, you can refer it. I'll be substituting ASV is nothing but here we calculated earlier, that is 100.53 SV, that is you have to calculate the spacing. So 150 into 10 raised to 3, that is acting force, that is ultimate shear force. So next, that is minus 86.6 into 10 raised to 3, that is you calculated 0.87 into Fy they have not given. If not given, you can assume as 415 multiplied by 300 minus 45, because it is dt is nothing but from the tendon to the top fiber, that is the distance, that is effective depth you have to calculate, that is nothing but 300 minus 45. Cover is they have given as 45 mm, so I will be deducting that. So you will be getting as SV in the first case, as you have to consider 3 cases here. First case you will be getting as SV is equal to 145.987 mm. So next you can calculate here minimum shear reinforcement. One more case you have to check it. Okay, ASV divided by B into SV is equal to 0.4 by 0.87 Fy. This also there in page number 48 only, you can refer it. No need to by heart the formula here. So I'll be substituting the things, so you'll be getting as SV in the second case as 605 mm, 605 mm, that is spacing. Next, last spacing you have to calculate, that is maximum spacing. SV is equal to 0.75 dt. So dt is nothing but 255. I directly substituted 300 minus 45. So SV is equal to, you'll be getting this much. So 3 cases you got it. One is here, 1, 2, 3. So out of these 3 conditions, whichever you are getting least value, that has to be considered. So in this, among this, which one is a least? This one. Okay, 145 mm is a least. Now you can write one sentence: provide two-legged vertical stirrups, at 8 mm diameter, stirrup of 8 mm diameter at 140 mm center to center. Please remember this one, you have to reduce the spacing, not increasing. Here 145.9 you got, you should not round it off for 146. You have to reduce it, so it makes a safe design. So next we will go with the detailing diagram, that is how you can do the detailing diagram, how it comes. Diagram has to be drawn.